Hello everyone, welcome to another video. So in this video I'll be explaining electrophilic substitution reactions of benzene. Now see, this is one of the important reaction from theory as well as from competitive point of view. Alright, so let's take benzene. Now see, in benzene we have these pi electrons, and we know that pi electrons are loosely held. Now if these are loosely held, then these electrons can be donated to any electrophile. So remember, any benzene or its benzene derivatives in electrophilic substitution reaction, they will behave as nucleophile. Nucleophile means the one which can donate electron. Now if these species are donating electrons, you need another species which should accept electron. So that will be electrophile here. Fine. Now, when this reaction takes place, what will happen? Any one of the hydrogen from this benzene, this will be replaced by the electrophile. So here what I'll get, in place of hydrogen, we'll be getting electrophile by the loss of that hydrogen. So this is the general reaction for electrophilic substitution reactions. Alright. Now there are different reactions under this, like halogenation, sulfonation, nitration, Friedel-Crafts alkylation or acylation. See, in all this, the mechanism is almost the same. The only difference you'll be seeing is in the electrophile. Alright, like for example, let's say you're doing this reaction and you get electrophile here. It is replacing that hydrogen, let's say. Now in this case, if I am doing nitration, then this electrophile, this will be NO2 group. So if I do nitration, the product we will be getting is NO2 here. But if I do halogenation, this electrophile will be nothing but the halogen here. So hydrogen will be replaced by halogen. Now if I do sulfonation, then hydrogen will be replaced by SO3H group. If I do Friedel-Crafts alkylation, then hydrogen will be replaced by alkyl group. If we do acylation, then hydrogen will be replaced by the acyl group. Fine. So basically the mechanism is almost same. The only difference is in this electrophile based on the reaction. Alright. So this is the general explanation for electrophilic substitution reactions of benzene. So we'll take this halogenation reactions and we'll try to understand the mechanism in detail. So we'll try to understand the mechanism of halogenation. So here I have taken the example of chlorination. So if you see in chlorination, you have benzene which will behave as nucleophile. So it will accept any one chlorine here, and this hydrogen will be replaced by the chlorine here. So we'll try to understand the mechanism for this. Mechanism. So in the mechanism of these reactions, there are total 3 steps, and the first step is generation of electrophile. Generation of electrophile. So here what will happen, that this AlCl3, this is basically a Lewis acid. So Lewis acid means it can accept a pair of electrons. So here we have chlorine ClCl and AlCl3. So due to the presence of this electron deficient species, what will happen? A partial charge will be developed on these chlorines. Where one will be delta negative, another is delta positive. And this delta negative will donate its electrons to the vacant orbital of aluminum. So then what we get? Cl, and this chlorine has donated its electron to Al. So a bond between chlorine and aluminum will be formed. Now since aluminum has gained electrons, it has a negative charge, chlorine will be having positive charge. Now next what will happen, this bond, this will break and all these 2 electrons will shift on chlorine. So we'll be getting chlorine, since this has lost this electron, it will be having positive charge plus AlCl4 minus. So this is the first step where electrophile will be generated, and in this case the electrophile is Cl plus. Alright, so this is the first step. Next, the second step. See, in second step what will happen? Benzene will attack on this chlorine, so a carbocation will be formed there. So second step is formation of carbocation, or in this case we also call it as sigma complex, formation of sigma complex, or we can call it as formation of rhenium ion. Alright, so here what will happen? Benzene we have, which is nucleophilic in nature, and this will donate its electron to chlorine. So here these two electrons, they can either shift on this carbon. So if it shifts on this carbon, we get negative charge here and positive charge here. This is one possibility. Another possibility is I can get negative here, positive here. But in this case, since it does not matter, we'll take it as it is. So here what will happen? This negative charge will be donated to this chlorine. So what we get? Benzene. These pi bonds will be as it is. And since these electrons are donated to chlorine, a bond between this carbon and chlorine will be formed and will be having positive charge here. Now here this positive charge is stable due to the resonance. So these electrons can participate in resonance here. So this is a resonance stabilized intermediate we have. So this is what we call as sigma complex or rhenium ion. Fine. So this is the second step. And in the final step what will happen? See, if you see this one and this one, we know that aromatic compounds are more stable. So in the final step, basically what will happen? The hydrogen which is present here, this will be removed and these electrons will shift here, and again we'll be getting the aromatic compound here. So in the final step, loss of proton will take place to regain aromaticity. So this is the final step. Okay. So loss of proton to regain aromaticity. So here I'll take this one, Cl here, and positive charge is present here, and we have this hydrogen here. So what will happen? Loss of this hydrogen will shift these two electrons here. So we'll be getting two electrons are shifted here, so a bond will be formed. So this is the final product we have. Alright, so this is the mechanism for chlorination reaction, and the reaction or the mechanism, this is similar for different reactions like nitration or sulfonation. The only difference you'll be seeing is in the first step, because in all these the electrophiles will be different. Alright, so we'll see one more example, that is for nitration. So if you see in the nitration, benzene, any one of the hydrogen, it will be replaced by NO2 group here. So in this case also the mechanism is similar. The only difference is in the first step. So in step 1, generation of electrophile. So here the electrophile will be what? NO2. And once the electrophile is formed, we will be getting, so in the second step, sigma complex will be formed. So same thing, benzene will attack on NO2 and we'll be getting this intermediate. And finally in the step 3, proton will be removed and the aromaticity will be regained. So if we compare this with chlorination, in chlorination also what we had? Benzene, and hydrogen was replaced by the chlorine group. Similarly, if I do sulfonation, in place of hydrogen we get SO3H. Fine. So the mechanism is same. So you should thoroughly study the first step. That is, you should know what is the electrophile here. Alright. So this is a brief explanation about this topic, that is electrophilic substitution reactions of benzene. Alright. So hope you understood it. If you have any doubts, you can ask in the comment box, or if you want me to do a video on any other topic, do let me know in the comment section. So that's it for today. See you in the next video.